Hello, I'm Sid D'Souza.
I'm Brian Gentry.
I'm Bryce Phillips.
And I'm Samuel Newman.
And
we are the
Hover
Craftsmen.
Buddies.
What?
The design cycle was an integral part of our process. We went through it multiple times to come to our final solution, a functioning hovercraft.
The first step of the design cycle is to ask, to analyze the problem and find the constraints. The first requirement is that the hovercraft needs to be battery powered or powered by an extension cord. The second is that it cannot use a commercially available hovercraft or helicopter parts. The third requirement is that it must be able to navigate an 18-inch wide track, which will be carpeted less than 50 feet in length, and you need to adjust for the turns. The fourth requirement is that steering must be accomplished by a mechanism on the hovercraft. The fifth requirement is that you cannot push or pull the hovercraft. The sixth is that it must be under a $40 limit, and the seventh is that there's a certain amount of time in which this all must be completed.
The next step in the design cycle is to imagine. First, we researched online to see the general idea of how a hovercraft works. Then we brainstormed a bunch of ideas to approach the problem. Most designs use a centrifugal lift fan to inflate the skirt and blow air under the craft. This creates a cushion of air that the craft can then float on.
For the plan stage of the design cycle, we combined our ideas together and we drew a diagram so we'd know what we had to build. And then we gathered materials from places such as online computer supply stores and hobby shops. We dismantled an RC car that we got at a hobby shop to use the chip and remote from for controlling our craft.
Next step was to create. For our original design, we used a round base and PC cooling fans. The cooling fans, we had two of them. We had a lift fan and a fan for steering. The lift fan was designed to blow air into a skirt, which would create an air pocket to lift the craft.
The final step of the design cycle is to improve. We figured out that a round foam base and PC fans wouldn't work for the hovercraft because they're not powerful enough and it's unstable. So, the round base was particularly difficult to make a skirt for, so we redesigned it to make it rectangular or square. To solve the problem of the skirt, we used a different material for the garbage bag. It's a little stronger, and we poked more holes in it so it gave it better lift. To replace the PC fans, we used propellers and motors from the same hobby shop. We got the RC chips, and then we got our final product. The final step is improve, which involves going through the cycle again and adjusting for your previous mistakes.
Besides the design challenges addressed in the design cycle, one major problem was parts not working how we expected them to. The PC fans we originally intended to use were too heavy and didn't give enough power to support the craft. Also, they didn't run in reverse, which made steering more difficult. To address these problems, we made multiple skirts and bases. Then we tested them to see which one worked best. We also used motors and propellers instead of the PC fans because they gave off more power and less weight.
At FEDD, our project made it all the way, half the way down the track. Compared to the rest of the competition, we were in the top 50%. But due to the track being on carpet, our batteries dying, and our motor overheating, we were not able to complete the entire course.
What would we do differently? Well, first, we'd start working on it earlier. We would practice on carpet due to the track being on carpet. We would not bank on one design. We would try a lot of different designs, a bunch of different prototypes, see which one works best, and go with that one. And last, we'd make sure that every single one of our parts works as expected to. If we did all of those, our hovercraft probably would have worked a little bit better.
Next year's freshmen, let me give you a little bit of advice. It's not as simple as it seems, but you gotta have fun with it. Don't procrastinate, and please learn from our mistakes. Go online, do a little bit more research, and try and see if you can find how the other designs fared at FEDD from previous years and what worked and what didn't. And reuse materials you have because you want to conserve as much money as you can to stay under the $40 limit.